Namaste students, I am Dr. Aziz Khan from the Department of Food and Biotechnology, Faculty of Agriculture and Veterinary Science, Jyoti Vidyapith Women's University, Jaipur. Today I am going to discuss about the method of the crystallization. How the crystals are formed and what are the different technologies which are used for the crystal formation and the crystallization. So the first theory which I am going to discuss about the crystallization is the draft tube baffle technology. Draft tube baffle technology. So this type of crystallization is especially designed to low viscosity product. Okay? The product which have low viscosity, which are not viscous. Okay, and this is for the low viscosity when in narrow crystal size distribution is expected. They are not a very good crystals. Okay, expected it will not be good crystals. So super saturated product will enter into a chamber which contains the mesicute. A super saturated product will enter into a chamber which contains mesicute. What is the mesicute? Mesicute is the mixture of the solution. Then the product crystallizes around the crystals that are already inside the vessel. Okay. The crystallization, the product will crystallize. Okay, it will crystallize around the crystals which are present already inside the vessel, and so that the solution reaches the saturation point. Okay. When it has been achieved inside the chamber, a stirred creates a stirrer. Inside the chamber, a stirrer creates a high circulation flow. Okay. A high circulation flow in order to give good repartition of the crystals. Okay. On the other side of the vessel, okay, the baffles create a quiet zone where an upward flow brings the smallest crystal out of the vessels. Okay. The upward flow will allow the small crystal out of the vessels. Only large crystals will be there. They are remelted and then put back into the vessel. Okay. This is the draft tube theory. So what actually happens in the draft tube theory? In draft tube theory, first there are some crystals which have already been created. So the experiment, the draft tube theory is for the uh, is used for the crystals which are already prepared, and it is used for the low viscosity product. In which first thing is the prepared crystals are recrystallized. So for that, the crystallization is conducted around the crystals which are already present, and in this chamber there is a stirrer. The stirrer will make high circulation flow. High circulation will give a good repartition of the crystals. So the crystal will reparty. Okay, they will be repartitioned, and after that, the waffle will create a quiet zone. It will create a quiet zone in upward flow. In upward flow, which will brings the small crystals out. Only large particles, large crystals will be there, and these large crystals will make crystals, and the remaining small particles will again remelt. Okay. They will be again remelted, and again they will be put into the vessel so that the crystals will be again formed. So it is used for the crystals which are not actually prepared properly. For proper crystallization, we apply a draft tube buffer technology. Next is the force circulation crystallization. Okay, the design of such a crystallization unit is very similar to force circulation evaporator. It is like force circulation evaporator. In this, a vertical tubular heat exchanger is really preferred due to the high viscosity. A tubular heat exchanger is there. Okay. And this type of crystallization unit is designed for the crystallization of salts. If we want to salt out some effluent, we can use the force circulation crystallization, which is the variant of the circulation evaporator, force circulation evaporator, and a vertical tubular heat exchanger is there, which provide high viscosity. Okay. When we heat, it is used for the heating, and when high heating is conducted with force circulation, then the crystals will be prepared. High heat condition with force circulation. Okay. The two things are there in the force circulation crystallization. And this type of crystallization unit is designed for the crystallization of salt out. Some artificial methods are also there for the crystallization, which include for crystallization, uh, we need super saturated. We need a solution to be super saturated, and some methods which can apply solution pooling, okay, artificial methods which we can use. First method is solution pooling, then addition of second solvent to reduce the solubility. We can add another solvent so that the solubility of the solute will be reduced. Then a chemical reaction can be conducted, and after chemical reaction, the solvent may be evaporated, which we have added previously. That solvent will be evaporated. So this is the artificial method. The influencing factor in the crystallization is temperature and the concentration. Okay, the temperature and the concentration. So cooling crystallization, evaporating crystallization are the two things. In the cooling, we cool the crystals, cool the solution at a low temperature, and in the evaporating crystallization, uh, the it is generating crystals by the evaporation of a solution at constant at a constant temperature. And most of the industrial crystallization are evaporative, means the at constant temperature crystals are evaporated. The example is the sodium chloride in the sucrose are the examples of the evaporating crystallization. What are the applications of the crystallization? Crystallization is an important downstream processing method in bioprocess technology, which is used in different chemical industries. And downstream processing can contribute to a large portion of the end product price. And therefore, the crystallization has an advantage. This is compared to other solid liquid separation operation such as distillation. Okay, since crystallization is a very energy efficient unit operation. In addition to the yielded product has very high purity level, and therefore wide scale of end use opportunities are there available. What are the equipments which are used in the crystallization? First is the tank crystallizers, which is used tank crystallizers, force circulation crystallizers, skepped surface crystallizers, circulating magma vacuum crystallizers, and Oslo crystallizers. So these are the instruments which are used in the crystallization. So in this lecture, I discussed about some techniques which are used in the crystallization, which include the draft tube, waffle technology, and the force circulation crystallization. two techniques. Similarly, some artificial methods were also discussed, which include the solvent solution cooling, addition of second solvent, chemical reaction, and the solvent evaporation. What are the effect? What are the influencing effect on the crystallization, and how cooling and evaporating crystallization is conducted? What are the application of the crystallization, different equipments which are used in the crystallization? So the question which can arise, explain the mechanism of the crystallization using different theories, different instrumentation. What are the application of the crystallization, and what are the factors which affect the crystallization? So I hope the students will better answer all these questions. So my lecture is over here. So if you have any query, you can ask me. So thank you very much.